Have you ever checked a product's ingredients list while shopping at a mall? If yes, you know the struggle of searching individual keywords on Google. Now imagine having a AI agent that can analyze the image and also perform web search on its own to give you better results. Sounds amazing? Well, that's what we will be building in this video. Introducing the multimodal agent using Phidata and Gemini 2.0 Flash. Gemini 2.0 Flash is the latest Google AI model with improved multimodal capabilities that can handle vision data and as well as image tasks. Meanwhile, Phidata is the open source platform that can help you build, ship, and monitor agentic systems. Now, you might be wondering why multimodal is useful, right? Let me give you some real world examples that I encountered while I'm using multimodal use cases. Suppose you're filling an online form and you encounter few keywords which you have never seen before. What you can do is take a screenshot, upload it to a large language or vision language model such as Claude, GPT, and Gemini, and then ask them to generate a result saying that, hey, how do I fill this particular form, and give them the context. So this is one use case where you can use it for filling the forms. And the second use case is again the same. If you are going for any shopping mall or supermarket, and if you want to get the details of certain product, what you can do is click the image, get the ingredients list, and ask the multimodal or vision language models. Lastly, if you are a student and if you are facing any issues with the diagrams that you are trying to understand in your syllabus, again, what you can do is you can leverage the AI technology by generating the responses by uploading the diagrams so that you can get the better results. So these are the few use cases where multimodal is very useful. Let's dive into today's video and build an AI multimodal agent using Phidata and Gemini 2.0 Flash. We will start off by exploring the architecture diagram and then with the code implementation. Alright, the first component is the multimodal vision language model. In our case, it is Gemini 2.0 Flash. So Gemini will make sure it will analyze the given image. The next thing is, if you want to perform a web search, this is where we will be using Tavily AI. So Tavily AI is an advanced search engine. Given to the user query, it will generate relevant sources and also the given context. So this is a very good tool that I'm using in most of my application. Until now, I'm getting the better results. So this is Tavily AI. And the next thing is we need an agent. So this is where I'll search model and I will drag a component. I'll just name it as agent. Whenever we are building any LLM based application, we need to have better responses. In order to get better responses, you need to write better prompt. Let me give you one case study or an edge case. Now let's take an example. We are trying to build product ingredients analyzer agent that can analyze the product image and then generate a report saying that, hey, this ingredients will affect this and what is the information about those ingredients. In this case, if I upload any irrelevant image or if I ask irrelevant prompt, I need to tackle those. This is where we will be using a system prompt where we will define the role to our product and also we will define what are the instructions that it needs to take. So here we'll be using two additional parameters to generate better responses and to play a role. So in order to play a role, I need to define a system prompt. And then in order to have certain instructions that a agent needs to follow, I'll be using a instruction parameter, instructions. So these are the four parameters that we will be using for building an agentic object using Phidata. So let me also add one more block. So here we will be using Phidata. Let me put this back, and this is built using Phidata. Also, let me change the color. Let me change the color of it. I'll put gray. This looks good. Now that we have, let me change the color of Phidata as well. I'll keep text font color to be white. Alright, so our agentic object is ready. Now let's bring the user so that user can upload the image or attach the reference from where we can take the image and then analyze it. So what I'll do is I'll use a user component, user, and I'll drag and drop here. So here we have a user. Now the next component is, let me bring the UI part where user will upload the image or attach the image file. Let me add camera. So user can either upload the image, not upload, I mean capture. If not, he can also upload the image. So these are the two options that the user can use whenever you are building a UI application. Alright, so we have the upload option and we also have the capture option. What we need to do is we need to define a variable called images. So this images is nothing but a list component where you are adding the image file that the user is uploading. So this is very straightforward. Let me just drag and drop this. Drag and drop. This looks good. Let me just change the alignment. Let me change the color to gray again. So now what we will do is whenever a user comes, first thing is he will select the image. Here this select of image is happening. Select the image and then this object, right, when it comes to agent object, you need to use a function called run. So you need to use a function called run. Agent dot run, you need to pass this image as the list. I'll repeat again, agent as a function called run. Inside this run function, you need to give this images as the list. Either it can be a run function or it can be print response. So in Phidata, you have print response as one of the function that can help you generate the result using streaming. So these are the two ways. Now what will happen is once you provide these images into the run function for agentic object, what it will do is it will generate a response. It will generate a response or the report that can be given back to the user. So you have the response. This response is given back to the user. Yeah, this is it. This is what we will try to build. We will have the user that will attach the file either via capture or the upload button, and then since our object of Phidata is already built, we will run a function that will attach the images in the list, and then you have the responses that will be given to the user. Let's try to build this via code. The first step is you need to install the libraries. The libraries that we need to install is Phidata so that we can build that agent object, then Google Generative AI so that we can make use of Google Gemini 2.0 Flash, and then Tavily Python for the tools integration. Later part, we will also show you how you can build this entire application using Streamlit. I won't write the code live, but I'll give a quick breakdown on how you can build multimodal agentic workflow on Streamlit. So I'll give the quick demo. Now let's try to build our agent component first. So what I'll do is from phi.agent, I'll import agent. I need to import the agentic workflow. So this is the agent object. And next from phi.model, I need to import Google. So Google is the provider name. So whenever you are using any model from Phidata, you need to add phi.model, then the provider name. The provider can be OpenAI, Grok, XAI, anything else. Here I'll be using Google. From phi.model.google import Gemini. Now from phi.tools, you have multiple integrations over here. What I need to pick is, I need to pick Tavily. There are other tools as well. Feel free to use those tools. In our case, we will be using Tavily. Now you just have to import Tavily tools. Alright, so we have the agent component, we have the Gemini LLM, and now we also have a Tavily tools. The next step is Gemini needs a API key. Tavily tools also needs a API key. So what I'll do is I'll just write import OS, and here I'll define Tavily API key, and then Gemini API key. Once you have this key, what we can do is we can save this inside an environment variable. You just have to add Tavily API key equals to whatever variable you have defined here. For Gemini, you need to add Google API key inside the environment variable, and then equals to, let's not confuse, let's just make it Google. Let me copy this and let me paste it here. Alright, so it's time to get the API keys. So in order to get Gemini API, what you can do is you can just go to aistudio.google.com. Once you are at Google AI Studio, on the left hand side you will see something called as get API key. You just have to click on get API key and you will see this API keys session where you can just create a new key and you will have your API key available here. Just copy that and paste it. Just copy that and you can paste it over here. So I have already created a file. I already have a file called utils. Inside utils I have a function called get API, so I will be using that function to get my keys. So I'm just showing you how you can get your APIs. So the next thing is I need to get the Tavily API key as well. So let me come back and search for tavily.com. You just have to log in. I'll just do login with Google. And once you are inside Tavily, you have a default keys that you can use. So what I'll do is I'll just use the default key which is available and I will just copy this particular key and then I will paste it inside my code base. Now that you know how you need to get the Tavily API and also Google API key, the next thing is let's build the agent object. So what I'll do is I'll just write from utils import get API, and now I will just combine these two components inside like this and then just run get API key. That's it. Alright, so now I have Tavily API key and also Google API key where I'm fetching it from get API, which is one of the functions that I have listed down in utils. So you can directly paste it here. If not, you can use other approach as well. Alright, so we have the API key setup. So this is the first step. First step is import the statements. The second step is to set up API keys, and now third step is to define the agent object. So as per our diagram, we need the LM model, we need Tavily, then we need instructions, and then we need the system prompt. So what I'll do is I will define the agent equals to agent. Inside agent I need to define model. Model equals to just copy this Gemini, and inside this you need to define the ID. So ID is Gemini 2.0 flash exp. So this is the model name that you need to use. As of now they have added exp as experimental, that needs to be fine. And the next component is tools. Tools is a list that you need to define, and inside this I'll just instantiate Tavily tools. Alright, so two components are ready. I have the model, I have the tools. The next thing is you need to write a system prompt and you need to write certain instructions. So I've already defined a system prompt. I'll be attaching the file in the description so that you can take a look at the GitHub repo. So the system prompt is: you are an expert food product analyst specialized in ingredients analysis and nutrition science. Your role is to analyze product ingredients, provide health insights, and identify potential concerns by combining ingredients analysis with scientific research. And you have a very detailed prompt. At last, what I've done is I've mentioned return your response in markdown format. So what we can do in Phidata is we can define markdown to be true, and then system prompt, there is a prompt, system prompt, and then we also have instructions. So these are the two parameters that we are yet to define, which is already existing in constants.py. Now instructions, as you can see, read ingredients list from the product image. Remember, the user may not be educated about the product. Break it down in simple words. This is very important because when I'm taking any shampoo, right, there are keywords which I don't understand. There are very high level because you need to be a domain expert. So this is where I want my agent to break it down in a very simple words. Look at the last point. In the last point you have use search tool for getting the context. So what will happen in this particular step is you're instructing the agent to first analyze the image, and if there are any ingredients which LLM doesn't have the context much, this is where you can do the search to get the context and then generate the result. So this is the capabilities of having agent that can use the tool and take action accordingly to which tools it needs to pick at that particular time. for the given user query, of course. So now you have this instructions and system prompt. So what you will do is, from constants you will import system prompt and instructions. So copy the system prompt, paste it here, and then copy these instructions, paste it here. Alright, so far we have completed 3 steps. We have our entire agent object setup using Phidata. The next thing is you need to select your images. So I'll show you two approaches. So this is our 4th step. There are 2 approaches. So the first approach is I'll use a file path. So here what I'll do is, you can check inside the image. I have the Bormita image, then I have hide and seek image, I have lace image, then I have a shampoo image. So what I'll do is I will pass any single file inside it. So what I'll do is I will copy this path, copy the path of Bormita, and then I will run this agent. So in order to run this agent, I'll run agent dot print response. Then you need to give a message. So the message is analyze the product image, and then as I told, you need to define a parameter called images. This images is a list. Images equals to list, and then define the path, which I've already copy pasted. So it's inside images. Inside images I am taking Bornvita, and now I need to stream it. So I'll just write stream equals to true. Alright, so we have completed the entire code. This is the first approach that I'm using, that is the file path. Now let me run this code. Python inference.py. So as you can see, it is message analyze the product image, and now certainly let's analyze the provided product information for Bornvita. So it is giving me the report. So this report format is instructed in the instructions keyword that I'm using. So as you can see, it's giving you the nutrition information. It's also giving you the key ingredients used, and below that you also have the analysis, and below that you have the health insights and also the recommendations. So this is the detailed report it creates, provided the system prompt and the instructions. So the tools are very simple. Just provide the image, use the multimodal capability of Gemini, and then use Tavily so that it can also get the context from the search. How cool is this, right? It's amazing. Now what I'll do is, I'll use a second approach. So second approach is image URL. So let me define agent dot print response. I will use the same thing. Let me copy the same thing. Let me copy this again, paste it here, and then I will comment this code. Comment this code, and instead of adding the path, I need to give a URL. So let's try to search for Messi. What I'll do is, I will add a Messi image and I will try to see if I can get the information or not. Copy image address, undo, paste. Yeah, this is ending with JPG and this is a valid image extension. Now what I need to do is, I don't need any response here because Messi is not a product, he is a goat, right? So Python inference.py. Finger crossed, I don't need to generate any response for this. It should just tell, that's correct. I cannot analyze the image because it contains a person, not a food product. This is the role playing which is defined in the system prompt. This is what I wanted to see. Now let's try to add a actual product. So what I'll try to search is, let me search for some face wash product image of let me search for some company. I'll use Beardo. Alright, so you have an image here, but I hope this is very small. Okay, this is good enough. This image is good. Copy image address. Yeah, this image should be good enough. So what I'll do now is, instead of Messi, I'll add this product image. Alright, so let me run this code again. Clear. python inference.py. So it should generate me a report. Certainly, let's analyze the ingredients of beardo tea tan face wash based on the product information. How cool is this, right? It didn't give me the results for Messi, but it gave me the results of whatever product I gave. Even though if you look at this image, I hope there was, okay, the product information is mentioned and it also has the ingredients. So this is great. It is able to generate the report that I needed. Now the thing is I need to dump my entire code inside a Streamlit application. So I'll show you the deployed app that I have created. Let me show you the app, ingredients.analyzer system app. So I've already deployed this app. I'll also show you how you can deploy it. So as you can see, this is the product that I'm using, example product, upload image or take a photo. If I take a photo now, let me take this photo. And if I ask it to generate information, it should again not generate anything. As you can see, it's telling I can analyze the text, but I'm unable to analyze the image. Is there anything else I can help with? So this means it's not able to generate. Now what I'll do is I'll pick any example products. So in our case, I'll be picking a chocolate drink. Now what I'll do is I'll click on analyze example. So what it will do is it will generate the entire report for Bornvita. Okay, again I pick Bornvita. What I can do is I can pick something else. I'll pick Lace. So now what it will do is it will generate the entire report for the product analyzation for Lace. So as you can see, it's analyzing the Lay's potato chips package and it's giving you the entire result. So if you notice one thing, in both the responses, you have the same format. It's giving you the overview, the nutritional information, health insights, then you have the potential concerns for the product. This is what I've been instructed the agent to do, and it's doing the same thing. This is it from this video, but let me quickly show you how to deploy this on Streamlit. So if you see here, these three components are same. You have phi.agent, import agent, then you have Gemini, you have Tavily tools. And for system prompts and instruction, I'm using the constants. So the additional parameter are file, image. The reason why I'm using file from images, I'm using the user to upload their image and also to capture it. These two features can be done using this particular library. Then you have Streamlit. So here again, what you need to do is you just have to install these three things. First, you need to install Phidata, Google Generative AI, Tavily Python. Then you need to install Streamlit. So once you have imported the statement, the next thing is you need to set up your API key. So we just have two API keys. I'm using Tavily, then Google. So one thing that you will notice now is I'm using Streamlit.secrets. Then Streamlit.secrets. This means whenever I'm creating any application on Streamlit that is using any API key, make sure to use secrets so that it's not exposed publicly on GitHub. And when you deploy it, you can go to settings and then attach this variable. So what I'll do is let me add Tavily instead of API key, and then I'll just add Gemini. So I'll show you how you need to pass the secret key when you're deploying your application. And once you have provided your environment variables, the next thing is there are few syntax. I'm using an example, right? If you look at this chocolate bar, chocolate drink, then you have this potato chips shampoo. This particular image, it's very big. I need to resize it. This is where I'm resizing the image whenever it's uploaded. And the next thing is I'm defining the agent as well. So this is a very straightforward code. I don't want to get into the detail because this is not the scope of this video. I've already attached the code base. You can follow along. This is the resize image. The next thing is I need to define the agent. So the agent code is same. You need to get agent from Phidata, define the model, system prompt, instructions, tools, and markdown. So this is the same thing what we have implemented here, right? Define the agent and then analyze the image. So what analyze image will do is it will call the agent component and then it will pass the images. So this image, it can be in any format. Either it can be sample image, it can be the captured image, or it can be the uploaded image. So this is the UI part. So in UI part, I am adding the title. So if you see, it is product ingredient analyzer. It's the same thing, product ingredient analyzer. Then you need to have this kind of UI feature where you can switch between the values. So in order to do that, what I'm doing is I'm creating the tabs. Streamlit.tabs.
what is my first tab, what is my second tab, and what is the third type. So this is how you define the tabs. Then for examples, you are also defining what are the references that you have. This is just like OpenAI, right? In OpenAI also you have few examples that you can choose and then it will generate the output for it. So I wanted that kind of feature over here. So you have that feature and then you define the column. So if you see, I'm defining the four columns for chocolate bar, chocolate drink, potato chips and shampoo. So this is done using columns. The next thing is I'm defining the code for upload function. So how you can upload? Streamlit has file upload option and then it can upload the image, resize it and then give it to the analyzing agent. So if you look at the analyze agent, this is the same code, get the agent and then pass the image option. So this image option can come from three different features. Either it is examples, upload or capture. So we have already looked into examples. Then this is the upload function. The same thing goes for capture as well. So in order to capture, again you can use streamlit.camera input, which will open the camera, then resize the image, and once it is resized, pass it to the analyze image. So analyze image again is the same function. So the code is very simple. Even if you tell Claude or GPT, it will generate you the code. What you can do is just take the screenshot of this, give it to the Claude or Gemini or OpenAI. It will give you the Streamlit code. The only thing that you need to worry about is the inference file, which we already covered. So this is it probably that you need to do. Now let's come back to the Streamlit application. How do you deploy it? So the first step is you need to open your GitHub. What you need to do is you need to create a file. So what I have done is I have uploaded the app.py, I have the constants.py and requirements.txt is very main. So app.py and constants.py are the supporting files. Requirements.txt file are whatever libraries that you are using, you need to upload that. So how do we do that? I'll show you the command. So whenever you're writing a code, right? Whenever you're writing the code, first thing is you create an environment variable. So once the environment variable is created, so this is the command Python 3. So this is the command on how you can create an environment variable, and then you need to install the library. So the installation library is Phidata, then you have Google, Generative AI, then you have Tavily Python, then you have Streamlit. So once you install this, the next step is very simple. So once you install all those libraries, you can just run pip freeze. So pip freeze will give you all the packages that you are using for that application, and then just you can copy paste this and give it inside requirements.txt file. So this is very important. App.py, requirements.txt, these are the only two files you need. Since inside app.py I'm using constants.py, I have uploaded that. That's it. Now what you can do is you can open share.streamlit.io. Here you need to click on create app, and once you click on create app, you need to link it with your GitHub. So here I'll be running product ingredient agent, then you have the main branch. So what is the main file? Where is your exact code written? So it is at app.py, and now you can give any name. I'll just tell multimodal agent Phidata. So this is the URL that I'll be using. Then what you can do is click on advanced settings. Here is where you need to add your secrets. So if you see whatever variable you use here, right? Whatever variables you are using inside secrets, copy the same thing. Copy the same thing. Tavily, paste it Tavily. Then paste your API key inside double quotes. Same thing for Gemini. Copy Gemini, paste it here, then save it entire thing. So I'll just give something over here. I'm just randomly typing. So once you save it, the next step is you need to click on deploy. Once you deploy your application, you can just run multimodal agent Phidata at streamlit.app and you will have your entire application ready. This is what I did to create this particular application as well. If you look at my GitHub profile, on the about section, I have the deployed URL. Since I already deployed, I don't want to deploy it again. I just wanted to show you how you can define secrets inside the Streamlit application. So this is the deployed URL, ingredientsanalyzer.streamlit.app. Well, this is it from the video. Next time if you are visiting any mall and if you have any questions regarding the product ingredients, don't forget to use our multimodal agent. Thank you so much for watching this video.